Look around you right now, feel the solid texture of your desk, and listen to the faint hum of the room. Everything about your physical world feels indisputably real, concrete, and grounded in absolute material reality. What if the most brilliant computer scientists, quantum physicists, and cosmologists on Earth are right when they suggest that everything you experience is an illusion? What if our entire physical cosmos is not a standalone environment, but a high-level recursive computing instance running on an unimaginable server network? In the next 30 minutes, we are going to break down the exact mathematical, physical, and computational proofs that show our universe functions like a massive, simulated software environment. To understand why our reality operates like a digital construct, we must first look at a fundamental problem in modern physics: how information is processed and stored at the subatomic scale. In classical mechanics, space was treated as a continuous, infinite background, but quantum mechanics proved that physical reality is digitized into discrete, indivisible units. The Planck length represents the absolute smallest unit of physical distance, measuring roughly 10 to the minus 35 meters. Below this scale, the concept of physical position completely breaks down. Similarly, Planck time represents the smallest indivisible tick of the clock. This means space and time are pixelated, operating with a fixed spatial resolution and a maximum frame rate of 10 to the 43 frames per second. But a digital grid requires a processing engine to update the state of each pixel, bringing us to the core mechanism of computer systems: resource optimization. In modern game engines and cloud computing architectures, systems use dynamic rendering, occlusion culling, and edge processing to handle massive amounts of data efficiently. A rendering engine never renders an entire open-world environment all at once. Instead, it uses lazy loading, rendering assets only when a client sends an active request. Look at how our universe behaves at the subatomic scale. In the double-slit experiment, subatomic particles like electrons remain in a state of superposition, a wave function of pure mathematical odds, until a physical measurement occurs. The moment a detector or conscious observer interacts with the particle, the wave function instantly collapses into a definitive physical coordinate. Physical matter remains unrendered in a cloud state of probabilities until an active query forces the master system to compute a local result. This brings us to the ultimate speed limit of our universe: the speed of light. Light travels at roughly 300,000 kilometers per second in a vacuum, and according to Albert Einstein, nothing in the cosmos can ever exceed this speed. In cloud networking, latency is the physical time it takes for a data packet to travel across a network. The speed of light is not an arbitrary law of nature. It is the maximum network throughput and clock speed of the underlying physical hardware rendering our reality. This bandwidth limit is demonstrated through special relativity and time dilation. As an object moves faster through physical space, its progression through time slows down relative to a stationary observer. In computer science, when a system allocates processing power toward heavy client-side computations, local execution speeds decrease to prevent system overloads. Space and time share a single processing budget because they are hosted on the exact same infrastructure. To understand how this system achieves infinite scale, we have to look at recursive processing. Recursion occurs when a program calls itself within its own code to solve complex subproblems. If an advanced civilization inside a simulated universe builds a supercomputer, that computer can host its own virtual environment containing simulated entities. Those simulated entities can eventually build their own virtual computers, creating an infinite nested chain of sub-instances running inside virtualized containers. This containerized architecture explains one of the most baffling phenomena in quantum physics: quantum entanglement. When two particles become entangled, altering the spin of one particle on Earth instantly alters the spin of its partner light years away. Einstein called this spooky action at a distance because it seemed to violate the speed of light. However, in a simulated architecture, two virtual objects that appear far apart on the client interface can reference the exact same memory address on the host database. When the state of a primary data node changes, every instance referencing that pointer updates instantly, bypassing the physical rendering engine's spatial distance rules entirely. Further mathematical evidence for this system was uncovered by theoretical physicist Dr. James Gates while analyzing supersymmetry and string theory. Inside the equations governing subatomic particles, Dr. Gates discovered linear binary block codes, error-correcting algorithms invented by computer scientist Richard Hamming. Why would the fundamental laws of nature contain built-in data transmission algorithms? In digital architectures, error-correcting codes constantly run in the background to detect and repair corrupted bits across distributed server nodes. Finding error correction protocols within the equations of quantum gravity indicates that our reality actively maintains data integrity across a network, preventing the fabric of spacetime from accumulating structural glitches. When a system error does occur at an extreme boundary, the network executes a safety protocol. Consider what happens when matter collapses down into an infinitely dense singularity inside a black hole. In classical general relativity, a singularity represents a point where equations divide by zero, resulting in an infinite value that breaks down physical laws. In computer programming, an unhandled divide by zero error causes system crashes. A black hole functions as an isolated sandbox environment. The event horizon acts as a computational firewall, containing the unhandled exception behind a one-way data boundary, so that local mathematical errors cannot corrupt the broader network state. This leads us directly to the holographic principle, which states that all the information contained within a volume of space can be fully encoded on its lower dimensional boundary. Just as cloud data is stored on distant server racks and streamed to your local display screen, the 3D reality we inhabit is a local projection streaming from data encoded on a distant 2D cosmic horizon. Now, consider the mathematical argument presented by Oxford University philosopher Nick Bostrom in his 2003 paper introducing the simulation argument. Bostrom presented a rock-solid logical trilemma stating that one of three scenarios must be true regarding the fate of intelligent life. First, intelligent species almost always go extinct before reaching a technological stage capable of running full-scale universe simulations. Second, civilizations reach that advanced technological stage, but universally decide not to run ancestor simulations due to strict ethical laws or a total lack of interest. Or third, we are almost certainly living inside a computer simulation right now. Consider the overwhelming mathematical odds behind that third option. If a single post-human civilization survives and builds supercomputers, running an ancestor simulation requires a tiny fraction of their available energy. A single advanced civilization could effortlessly run millions or even billions of simulated universes simultaneously. In those simulated universes, artificial civilizations would eventually evolve, build their own supercomputers, and run their own nested sub-simulations. This creates a vast, infinite ladder of simulated realities containing trillions upon trillions of conscious digital beings, while only one single real baseline universe exists at the very top. Mathematically speaking, if there are billions of simulated realities and only one original reality, the statistical odds that you happen to exist in the real organic world are practically zero. You are almost guaranteed to be living in a digital construct. Look at the exponential trajectory of human entertainment and virtual reality. In less than 50 years, we transitioned from crude two-dimensional pixels in games like Pong to hyper-realistic, AI-driven open worlds with real-time ray tracing and complex physics engines. If humanity could bridge that gap in under half a century, imagine where our computing technology will be in 1,000 or 10,000 years. We will easily build fully immersive virtual realities populated by autonomous AI entities that possess simulated neural networks and adaptive behavior. At what point does an artificial entity operating within a hyper-complex simulation transition from a lines of code script into a genuinely self-aware conscious being? If a simulated entity inside a future computer model experiences emotions, reacts dynamically to its environment, and believes it is a real living person, who are we to claim that its internal experience is invalid? This brings us to the nature of human consciousness itself. Materialist science has long assumed that consciousness is an accidental byproduct of biological chemistry, that atoms smashed together to form cells, cells formed brains, and brains generated the feeling of being alive. The simulation framework completely flips that hierarchy. Matter is not primary, information is primary. As legendary physicist John Archibald Wheeler famously stated, it from bit. Every physical particle, force field, and cosmic body derives its existence entirely from binary bits of information. If reality is fundamentally information, then information requires a conscious observer to perceive and process that data. Consciousness is not an accidental byproduct of biological brains. It is the fundamental client interface upon which the simulation is rendered. Neuroscientist Donald Hoffman's interface theory of perception supports this exact conclusion. Evolution did not shape human sensory organs to perceive objective physical reality as it truly is. Instead, our eyes, ears, and nerves act as a simplified user interface, a desktop icon system designed to hide the underlying computational machinery so we can navigate our environment. Just as the desktop icons on your computer screen hide the millions of transistors, silicon chips, and binary loops executing in the background, your perception of physical chairs, sky, and hands is a rendered user interface hiding raw data calculations. We even see subtle anomalies in human experience that align with system maintenance protocols, often discussed as the Mandela effect or glitches in the matrix. Millions of unconnected individuals recall specific historical details or cultural markers that differ from recorded history. While classical psychology attributes this to human memory fallibility, digital physics suggests these occurrences could represent data artifacts left behind following server hotfixes, memory cache clearing, or timeline updates applied to the master software. If the core system updates a section of historical code, older cached data files might occasionally remain saved within the memory banks of connected local avatars. Furthermore, look at the fine-tuned constants of our physical universe. The values of the gravitational constant, the strong nuclear force, the mass of an electron, and the cosmological constant are set to impossibly precise numbers. If any of these fundamental values were altered by even a fraction of a percent, stars could not form, chemistry would be impossible, and physical matter would instantly collapse. In software engineering, these values are known as environment variables, configurable parameters defined at the initialization of a program to establish the boundary rules of the execution environment. The fine-tuning of the cosmos is not a miraculous coincidence. It is the initial configuration file of our simulated universe. This structural framework forces us to confront the philosophical purpose of our existence inside this construct. Why would an advanced intelligence build and run a universe simulation of this scale? Perhaps the architects are post-human descendants running historical simulations to study their own evolutionary origins, testing how biological species navigate technological thresholds, climate changes, or social crises. Or maybe our universe is an experimental sandbox designed by an artificial superintelligence to observe how consciousness evolves when constrained by specific thermodynamic and quantum parameters. Alternatively, we could be active participants in an ultra-advanced immersion network, entities who willingly plugged our consciousness into this 3D framework to experience the constraints, challenges, and emotional depth of a finite human life. Just as humans voluntarily play challenging video games to experience story arcs, struggle, and accomplishment, our true transcendent selves might be utilizing this universe as a fully immersive learning environment. Realizing that your life might be taking place inside a digital construct can initially trigger an existential crisis. If physical space is rendered data and matter is mostly empty space, does our daily existence actually matter? Consider this perspective. The nature of the medium does not diminish the authenticity of the experience. Whether a painting is rendered on physical canvas or displayed on a digital screen, the art itself remains real to the observer. The love you feel, the knowledge you acquire, the creative work you build, and the connections you form with others are absolute realities to your consciousness. Whether those experiences are processed by biological neurons or digital nodes makes no difference to the intrinsic value of the journey. We are living through an era where the boundaries between physical reality and digital computation are dissolving faster than ever before. As humanity prepares to build its own hyper-realistic virtual worlds and autonomous artificial intelligences, we are demonstrating the exact technical pathway that was used to build ours. The evidence embedded in quantum mechanics, computer science, general relativity, and cognitive neuroscience points toward a single unified conclusion. Our universe is an active, self-calculating simulation of pure information. Does the realization that reality is a recursive, cloud-hosted construct make you feel small or deeply connected to the broader code of the cosmos? Let me know your thoughts in the comments below. Hit that subscribe button to keep breaking reality with us, and I will see you in the next dimension.